Hey folks, my name is Jason. I'm a technical evangelist at Buoyant, and today I'm going to talk to you about how mTLS works within a service mesh using Linkerd as an example. So let's just dig into this and see a bit about how it works. So I'm going to run 3 applications in my Kubernetes cluster. I'm going to have application A, I'm going to have application B, and I'm going to have application C. So application A, B, and C all talk to each other. By default in Kubernetes, this is likely going to be plain text traffic, HTTP traffic between our applications. But we want to make that more secure because we don't necessarily trust that every actor inside our Kubernetes cluster is someone that should be allowed to read all the traffic between the different components. So let's start by installing Linkerd. So we're going to add our Linkerd control plane. And that Linkerd control plane comes with components that allow us to issue certificates, verify identities, and secure the traffic between our components. So the way it's going to work is this A, B, and C application inside of our pod is actually a special container running inside our pod. So we have our A, B, and C application containers, and then with the service mesh, we're going to add a special sidecar container beside every single one of them. In our case, that sidecar is the Linkerd proxy. And that sidecar is going to change the way these components were talking. So instead of A talking directly to B, talking directly to C, now it's going to go from application A to our sidecar, from sidecar A over to the sidecar on B, down to our application. And that gets repeated with every single bit of communication between these apps or workloads. And so while A, B, and C here still believe they're having plain text communications between each other, the Linkerd proxy has stepped in the middle, intercepted that communication, and used a certificate that actually got issued by the Linkerd proxy. So the Linkerd proxy, it validated the identity of each one of these workloads. And it issued us a little certificate that we can use to securely communicate on the network. This certificate identifies pods of application A as A pods, pods of workload B as B pods, and pods of workload C as, you guessed it, C pods. And now, every bit of communication between these apps are always encrypted, and we know when A talks to B, whether or not that really came from A or whether it came from someone else. mTLS provides us encryption in transit, which is handy, but it also provides us authentication or identity for every one of encryption. There we go. It provides us encryption and identity for every one of our workloads. So we know when things are talking, who they are, and what their identity is on the network. And again, that encryption or that TLS is bidirectional. So we know both the identity of the client and the server. mTLS is important because it allows us to ensure that we're able to trust who a given workload is based not on their network ID or some, attestation from that application, but instead based on the cryptographic identity that is kind of the underpinning for all secure communications on the internet. I hope that's been helpful. Thank you so much.